Hello, everyone.
Chaos testing at scale and test resilience frequently across your organizations. Our speakers, Siddhartha Arora, an enterprise architect at Nagarro and an expert in designing resilient systems, and Tarun Khosla, a senior staff engineer at Nagarro, will demonstrate Nagarro's resilience framework, which is used by leading enterprises across the world. So by the end of this workshop, you'll basically have an understanding of how to improve resilience continuously and also scale the engineering efforts. So yeah, get ready to take your resilience to the next level with Nagarro.
Thank you, Shane. Hello, everyone, and thank you for joining this workshop session today, where we would be talking about how the framework that we have built is helping our clients continuously improve resiliency and helping them build applications that are resilient, reliable, scalable, and fault tolerant, with the primary goal of providing uninterrupted and consistent user experience to end customers. I am Siddharth from Nagarro. I am an enterprise architect experienced in technology consulting, digital transformation, cloud engineering, and resiliency engineering. Joining me today is Tarun, who is a senior engineer with Nagarro and is one of our resiliency experts. We all talk about digital immunity and what needs to be done to be ready for situations we have never anticipated for. Many large organizations have enabled themselves with a variety of tools available in the market. Having the best tool available does not always give you the best of solutions, especially if you're not using it correctly. For example, having a code analysis tool may probably not help with identifying issues related to infrastructure failing. Similarly, by just having an observability tool in your landscape will not help if you do not have a robust alert management system in place or a process to address the incident when it occurs. Even if IT teams are building applications with the most modern architecture in place, I have seen even in such landscapes where issues like long page loading times, frequent timeouts, out of sync components, and other similar issues still prevail. It is not the problem of one tool or many, it's a gap in the process that needs to be filled. It is the confidence in the process and people that is required to make it work. We need to set up gates, checkpoints at every step to ensure we are using all the components to the best of their ability. I would like to share with you some interesting findings that we did find from surveys that we conducted amongst our very own customers in different industries, from banks to ISVs to Fortune 500s. And what we found that more than 80% of the customers reported that they have witnessed a disruption or an outage of their critical services every year. And more than 50% of them either do not have a DR setup or do not conduct DR drills. Uh, this is not because they don't have an IT infrastructure to set it up. If they are hosted on cloud, they are either depending upon the public cloud to manage that, or for on premise installations, they simply were not confident to conduct DR failover tests. These disruptions that they faced lasted somewhere between 3 to 12 hours on an average, and the teams were more or less stretching out to find the root cause during the outage and restoring all the services back to its full glory. Based on their analysis, roughly 74% of the outages were due to infrastructure and environment related, and the remaining were attributed to either issues related to design or code. Therefore, there is a need to have a synergy between people, process, tools, technology, and infrastructure now to provide it just works experience to your customers. Our NREF frameworks solves this very problem. So here is quickly the agenda for the next 40 to 45 minutes, where we will start by providing an overview of what is Nagarro's Resiliency Engineering Framework, or NREF that we call, and then apply the framework for a sample application and run an actual chaos test using the framework as a demo. We will also talk about how the framework can scale to support large organizations and development teams. We will also cover key architecture and design principles to build resilient architectures. Then we will look into the solution accelerators that our framework provides that you can use to accelerate your journey to building resilient applications. We will have time for a Q&A towards the end as well as in between the session. So let's get started. Nagarro's resiliency engineering framework is built, matured, and proven over the years to measure, learn, and build solutions that reliably deliver a consistent user experience and help customers accelerate their journey to building highly available and resilient systems. The framework is developed through focused interviews with 20 plus projects within our organization with the teams and understanding how they helped clients crawl, walk, and run the journey to high availability, resiliency, and reliability. The framework provides a structured approach to achieve zero defects, zero delays, reduce downtime, and ensure zero danger, making the entire ecosystem inherently resilient to failures. We have curated a framework that supports our different engagement models with customers depending on where they are in the resilience journey. So, how do we start? We start with the discovery step, which essentially answers the fundamental question of where do we start? The discovery phase is primarily where we try to understand each customer's unique landscape, their business needs, and define the right resiliency strategy that is aligned with their business objectives and goals. We conduct workshops to identify their mission critical applications and the critical user journeys. We then perform a deep dive on how their architectural canvas looks like and how it comes together to effectively deliver what it intends to deliver. We understand their technology stack, the factors influencing the technology choices. We also look into their deployment architecture to understand how the components are deployed and interact with each other, and how they can be scaled up or down to meet changing demands. We also understand the observability, monitoring, and alerting setup. In addition to that, we also look at performance and security requirements. So, how do we do it? Essentially, we interact with various business and IT stakeholders to understand the key pain points, applicable SLAs, their growth trajectory in terms of how they are, forecasting their growth in the next couple of years, and draw an implementation roadmap. I think we've been hearing about it a lot. Having a robust observability platform is an absolute must, I think, as it provides a way to gain insights into complex software systems, allowing us to detect and diagnose issues more quickly, reduce downtime, and improve the overall performance and reliability of the applications. In the measure phase, we help organizations set up such a robust observability and monitoring platform using various open source platforms or commercial products based on their needs and fitment. It helps organizations measure key metrics such as response times, error rates, resource utilization, and observability can help organizations identify areas for improvement and optimize the performance and reliability of their applications. In our experience, we have seen that many customers they do have application and performance monitoring tools in place. However, in most cases, we have found them not being configured and used optimally. Uh, for example, for one of our clients, they had an industry standard tool for application and performance monitoring. However, they were missing on several key implementations, such as full stack transaction traceability, building user journey specific insights, clear definitions of SLIs and SLOs for the critical services, automated incident creation, alerts for issues and events, forecasting, and configuring dashboards for business KPIs and values, right? We help our customers climb the observability maturity model to a more proactive and intelligent monitoring. We help them identify and define SLIs and SLOs for critical user journeys and create dashboards to monitor them. Our reference architecture to implement observability factors in instrumentation, tooling, alerting, automation, and visualization at application and infrastructure levels. In the learn phase, we implement chaos testing, simulating different failure scenarios such as hardware failures, network outages, or software crashes, and evaluate how well the system or the application responds to these events. We perform SLI benchmarking, which is essentially measuring and monitoring the performance of a service against defined SLIs. We begin by testing in lower environments repeatedly till we gain confidence in the system before moving it to production. We follow an incremental approach for running tests in production. For example, run the tests in non-peak hours multiple times initially. This is one of the approach that we typically take, which ensures minimal impact in case of an unintended outage and increases the confidence in the overall system that we are building. The goal here is to identify potential failure points and weaknesses in a system or application, improving fault tolerance and availability, and reducing the risk of catastrophic failures. The primary objective also being that the SLOs that are defined are not breached under these varied conditions, which is enabled through constant SLI monitoring. The build phase comprises of remediating and transforming the application to achieve the desired resiliency. The insights and learnings that we gain from testing earlier enables us to identify the corrective measures that are required to address resiliency issues. Remediations can vary from being as little as just reviewing and changing application and infrastructure configurations, probably, right? For example, those related to scalability, configurations, timeouts, retries, or they could be as large as modernizing or replatforming some of the application components and applying the right design patterns. Towards the end of the demo, we would also be covering a few key patterns that can be applied to build highly resilient systems. We have developed multiple reference architectures across different technology stacks and hyperscalers that provides standardized architectural blueprints that outlines best practices and recommends solutions for a particular type of a system or application. Once the remediation is implemented, we repeat the entire measure and learn cycle continuously till we achieve the target resiliency. So today, for a demo, we will see a practical application of this framework on a sample web application that simulates a bank's payment processing network, allowing users to create bank accounts and complete transactions. This is the Google provided Bank of Anthos application that we have deployed in GCP running on Google Kubernetes engine. This is a web-based banking app, for those who are not aware, that uses a number of microservices. We will apply this framework to identify a critical use case scenario, see what SLIs and SLOs can be applied, understand the current baseline, run chaos tests to see how the system behaves, and more importantly, does it provide a consistent user experience? And finally, what key patterns that can be applied to make the application more resilient? As part of the discovery, data is gathered using predefined questionnaire covering areas of critical user journeys, the technology stack, the deployment architecture, the integration architecture, the SLIs and SLOs, observability, incident management, and operations. This helps us gain a deeper understanding of their systems and processes, identify areas for improvement, and develop a roadmap for improvements over time. Post this session, a sample questionnaire template covering some of these aspects would be shared for your reference that you can have a look offline. So once the discovery is done, a multi-dimensional analysis is conducted with the data that has been gathered and mapped to our NREF resiliency maturity model. This model basically indicates where the organization stands in the journey of achieving resiliency and decide on what approach we need to execute in the areas of observability, benchmarking, modernization, uh, shift left, which we've been hearing since last 2 days, which is essentially integrating chaos testing in the early stages of SDLC, and shift right, which essentially is running chaos tests in production. Our NREF resiliency maturity model has 5 stages. First is the define. At this stage, the organization is just about to or just beginning the resiliency journey, where they do not have clear SLIs or SLOs defined, or they do not have a robust monitoring platform in place that provides a comprehensive view of a system's behavior. The next stage is diagnose. This is where SLIs and SLOs are defined and monitored to some extent, but organizations are not running any chaos tests. At this stage, we help them define their resiliency parameters and run chaos testing to help them baseline their current resiliency. The next stage is transform, where we help customers modernize and remediate applications and design to achieve their target resiliency. We also integrate chaos testing as part of the development pipelines for continuous validation. The next stage is optimize, where we help them build resiliency scorecards and trends and really enable them to run tests in production. The final stage, which is the mature, which is the ideal stage where we want to be, is where the platform can predict failures or outages based on intelligent forecasting. It's a long journey, but we enable our customers and take them through the different maturity levels through a detailed and a structured roadmap. Okay. So what we're going to do is by taking a demo banking application as part of the discovery phase, we reviewed the architecture and have considered the payment transfer service for demo purposes as a critical user journey for the business. We reviewed the architecture to identify the critical services involved in payment processing. So as you can see, we were focusing primarily on the front-end service, which is marked in the green, and the ledger writer service that are used for the payment transfer user journey. The front-end service calls the ledger writer microservice to simulate a payment transfer transaction. The ledger writer persists the transaction into the database. This service also reported a low customer satisfaction score in the customer service. So this is the target service that we're going to consider for a demo. We will cover the architecture in detail in the subsequent slides just before the demo. So moving on, with our assessment, we learned about the existing state and planned for commencing chaos tests. There could be multiple scenarios and hypotheses created and tested, such as VM crashes, memory leaks, resource starvation, zone outage, among others. But for a demo, we will run an experiment to inject a network latency fault between the front end service from which a user initiates a fund transfer and the ledger writer service that gets triggered and performs the fund transfer operation. We will inject a latency of 800 milliseconds, and the primary goal is to ensure application is reliable, uh, resilient, and that the application does not breach the defined SLO that can negatively impact the end user experience. Moving ahead to the next phase, in measure phase, we ensure that the SLIs and the SLOs are defined, baselined, and continuously monitored before we run the chaos tests. By monitoring these metrics over time, organizations it helps them gain visibility into how well their systems are meeting their service level objectives and whether they are meeting the needs of their users. By defining and monitoring SLIs that are directly tied to business outcomes, organizations can ensure that the systems are delivering value and contributing to overall business success. The observability setup for the demo that we will use is implemented using Prometheus with Grafana dashboard for visualization. So talking about the SLIs and the SLOs, so here is the view of the SLI and SLO that are defined for the payment service that we will track and monitor during our chaos testing. So just very quickly, SLI or the service level indicator is essentially the a measure, typically in a ratio or a percentage of a specific aspect of a service's performance. SLO, on the other hand, is the target or the goal. For our purpose, the SLO defined for the payment service is that 98% of the total payment requests should be successfully processed without any errors during a given point of time. The SLI metrics that we are going to use to measure this is the success rate. We have created a Grafana dashboard setup, which we will see subsequently, through which we can constantly monitor the current success and error rates of payment requests coming in at regular intervals. We have created a sample template to capture SLIs and SLOs for services, which we will share after demo for your reference. Moving on, here is a snapshot of the steady state of the payment service. The snapshot was taken by executing the load generation scripts and simulating roughly around 100 payment transfer transactions. As you can see, there was only one payment transfer request which has failed for whatever reasons, which leads to an error rate of 0.99%, as shown in the center. Below that, you can see the two SLIs that we are monitoring and the state. The error rate SLI of 0.99% of the payment service, I think, is well within the defined threshold of 2% if 98% is my target for success. And everything I think looks just fine. Just so that you get an idea, the payment service was running in three pods on three different nodes within the Kubernetes cluster when the load was run. This, in general, represents the healthy state of the service where it is well within the defined SLOs. So before going to the demo, very quickly, uh, before we run the actual experiment and see the impact, let us have a look at the key building blocks of a robust observability platform at a very high level. Application components run on different infrastructures such as VMs, bare metals, Kubernetes, and logs that are generated by these components are collected typically using monitoring agents or log exporters and sent to processing pipelines for ingestion, transformation, and storage. Valuable insights related to availability, performance, errors, resource utilization can be gained through log visualization tools. The extended observability components that you see below basically are used for advanced analytics, forecasting, and generate other business intelligence reports. The observability platform should be integrated with a ticketing system for incident management and alerting service to send out alerts. Moving ahead to the next phase in NREF, the learn phase is where we actually run the identified experiments and validate our hypothesis. Once again, today for a demo purpose, we will be running a live network latency experiment, injecting a latency of 800 milliseconds between the front-end service and the ledger writer service, which is responsible to process the payment transfer. Both these pods, as I mentioned, are running in different nodes within the cluster, and the payment service is running within three pods with different nodes. So as part of the demo, also, since we are talking about shift left, we have integrated resiliency testing in the development process to adopt shift left. With the shift left approach, resilience practices are incorporated earlier in the process, such as during the design or development phase. By detecting and addressing issues, by detecting and addressing these issues early on, the system can be made more resilient, which can ultimately improve its ability to withstand and recover from unexpected events and disruptions. So here is a quick overview of the DevOps flow for the application. The Chaos experiment execution has been integrated with the Jenkins build pipeline, which we will see during the demo, and to be triggered automatically based on certain events. For a demo purpose, the Chaos testing pipeline will be triggered as part of the build itself. The payment service of the application deployed on GCP will be tested for network latency. And we will monitor the impact live on the Grafana dashboard and see how the system behaves. Moving on, just before we start the experiment, this is the high level architecture of the sample microservices banking application once again that we would be using for the demo. The application is made up of different components and services, mainly the front end service, which we are going to use, which is a web based user interface written in Python, from which a user can log in and perform various actions such as retrieving the current balance, view past transactions, and of course transfer funds. The other two, user service and contacts, are essentially other microservices written in Python to manage user accounts and authentication. The ledger writer, again, which is going to be our target service for our chaos experiment, is written in Java, which accepts and validates incoming transaction requests for fund transfer before writing them to the ledger database. And the other two, balance reader and transaction history, they kind of provide readable cache of user balances of previous transactions. The application also comes with the load generator scripts that we would be leveraging, which continuously sends requests imitating users to the front end service and simulating transactions. We will use the provided load generator scripts in a demo to simulate user logins and payment transfers. The application, again, one more time, is deployed in GCP Kubernetes cluster, and the ledger service is running on three pods on three different nodes. Okay. So before we begin, are there any questions?
I
Okay.
see one, Siddharth. I think that if you want to take up, when you run chaos tests in production, what are the typical challenges you see or one should watch out for?
Okay. So I think in our experience, I think in almost all the implementation we have done or we are doing, I think there is always an apprehension on the customer side to run these tests in production, right? And that is for obvious reasons, right? From a customer standpoint, why do I want to intentionally disrupt my environment when everything seems to be running fine, or vice versa, right? When something is not running fine, why do I really want to make it worse, right? However, once you are able to convey the business value that they would be getting out of it, I think half the battle is won, right? Now, coming to the part of the typical challenges that we have faced, I think we've been talking about it all this time. The observability platform, as I said, right? So there is we've seen an absence of a robust observability platform that can help you know exactly what's happening in your system, right? Um, and in the absence of that, that becomes a little challenge because sometimes you cannot measure what you can't see. And in many cases, we have seen where systems lack automated recovery, right? So in this scenario, there is always a dependency on manual intervention to restore services back after an attack. Documented SOPs can help in this scenario. However, there is still a manual effort involved. And I think another challenge or typically becomes that we see is the availability and synchronization of different operational teams in standby, when we run tests in production, because we need the support to resolve any unexpected outages or disruptions where the blast radius is wider than a hypothesis, right? There's always a possibility. So that is a situation where we don't want to be in, but it is important to run the test and validate the hypothesis repeatedly in the lower environments until we are sure of the blast radius and impact.
Got it. I see one more question. I'll also show it on stage. So it says it's by Jayaprakash. It says, how do you see ROI for chaos engineering?
So ROI for chaos engineering. So I would say, see, essentially, eventually we want an uninterrupted and better customer user experience for the end users, right? So from a business perspective, it makes sense if we can identify. So typically, there are various ways where you can measure, where approaches that you can take. There are instances when people try to quantify the kind of outages that they have to make sure how you can prevent it. So there is one of the way where you can take that kind of an approach. But I think more importantly, sometimes something is based on, it's a brand value sometimes, where you really cannot put a number to it. But that's something that you really want to make sure that you don't tarnish that.
Yeah, makes sense. Cool.
Okay, so
Okay, there is one more question, but I think I'll do the demo first, and then we can
sure.
take that
Yeah,
question.
we'll take
Okay.
it towards the end.
Uh,
So all right, without further ado, let us together see chaos testing in live action, and at the same time view the impact of the payment service SLI. With that, I'll hand over to Tarun to run the experiment. Thank you. Over to you, Tarun.
yeah, thanks for that. Okay, I'll start sharing my screen. Great. What we have done is for the purpose of this demo, I think although the attack and other things have been briefed before, but we have integrated Chaos as a part of the normal build pipeline. The normal build pipeline has stage for static code analysis. You can integrate it. So this is just a demo. So, but yeah, the usual stages could be this. So it is static code analysis, unit testing, then you build, you deploy, and then you can run a Chaos test. So what I'm going to do is I would mimic a developer. I would go and run this. What happens behind the scenes is what I'll show you. Uh, but before that, I would also like to show you the Grafana dashboard, which is currently showing that, okay, 9 out of 1 payment has failed. We will turn it to last 30 minutes or so. How many payments are failing? So from last 30 minutes, we see 1 payment has failed. So it looks system is healthy for last 30 minutes. It depends how your observability dashboards are set up. We will be monitoring most of the things here. And yeah, so I'll go and run the build pipeline, and then we'll see further what happens next. So once this build pipeline is triggered, so there is a stage for chaos testing, which in turn is actually calling another pipeline, which we have integrated. So we would go and see what is happening at that pipeline and what are the different stages that entails. So there are a few stages that this chaos testing pipeline, which was triggered from the build pipeline, includes. First one is validate target. So if you're running this in your development environments or in lower environments, so you do not want to attack something that is not meant for chaos. So you might have a database that might not have a backup, or that might not even have a replica running that could act. So you would end up running chaos, and the whole development environment might come down. So it basically ensures that you are validating the target. In terms of Kubernetes, there are labels and annotations that help you do the same. So there's a validation in terms of the target that we are currently running. Then parallelly, it is generating a load, which is using JMeter. So we have integrated JMeter. You can integrate other tools also. As Sid said, there's Locust, there could be Load Runner, depending upon what kind of performance tests you want to run, so that we could see what is happening. Behind the scenes, it is triggering a chaos. Chaos, as told previously, is actually a network latency attack, which is for 800 milliseconds and is running for a period of 1 minute. Now, this attack was configured as a part of the previous build pipeline itself, and all those tests are configurable. So you can actually configure multiple attacks also. For the purpose of demo, we have integrated one attack, but if you're running simultaneously a lot of attacks, you can do the same. Okay, so since the chaos is running and it is up, let's go and see how. So what has changed is now currently, as you see, the number of payments are currently three payments have failed, we have set up a threshold of 98% payments should pass in an interval of 30 minutes. So if you see there's currently a breach of SLO, which we were expecting not to happen. We were hoping that 98% of the payments would be successful. We will wait for the chaos to complete so that we could also see that whether we once we are back to normal, does it recover, or do we need to make changes for post chaos as well? Because there are times when systems do not recover from chaos, or you might need an additional effort to actually go and see in your development environments or in other environments as well that okay, this is something that needs more care or more resiliency need to be built because it is not recovering even when the problem has been resolved. Okay, so I see the chaos is still running. I can check. It is. Yep, it is completed because I know that we have set up again. How do I know? Because we have set up a load, which was for 100 users. Prior to this, we did 50 users were already there. So a current total of 151 payments were made, out of which four failed. We expected almost none of them to fail. Uh, it could be as per the criteria that you have set, but it did not meet the expectations that were set for the purpose of the demo. Again, for some people, it could be fine depending upon what you are trying to establish or what you are trying to achieve. You have to set up your matrices accordingly. And I think Sid will talk more about that as well. So yeah, this was a plain simple demo, and how to fix this, how to make a better resilient architecture. I will hand it over back to Sid so that he could tell you more about that.
Sure. Thank you, Tarun.
Yeah.
Let me just share my screen once again.
Looks like you're muted, Siddharth. Uh,
Oh, I'm sorry. Yeah.
it's I can hear you now. So you can go ahead.
Okay. Thank you, Tarun. So we saw how probably an unexpected failure and disruption, uh, like a network latency within the environments, can possibly lead to the breach of SLOs, eventually resulting in poor and negative customer experience. Right? There could be various reasons, which we will come to it, but actually, so this actually kind of helps us identify vulnerabilities and discover opportunities for remediation to improve resiliency. Building software resiliency involves improving the design, implementation, and operation of software systems to make them more fault tolerant, adaptable, and scalable. There are some key architecture and design patterns that can be applied to build scalable and resilient applications to ensure that they can continue to operate uh, even in the face of unexpected events such as hardware failures or network disruptions. Very quickly, here are a few key principles and best practices to consider. Design for failure. I think always assume that uh, the components will fail at some point and design the application to handle such failures. Use distributed architectures that run across different workloads and can improve fault tolerance. Monitor and observe to detect issues and failures in real time and set up alerts. Automate recovery to minimize downtime and reduce impact of failure. Uh, Test resilience, always simulate failures using chaos testing and see how the application behaves. And finally, continuously improve the resilience of the application by regularly reviewing and updating the design. Let's look into these in more details in the next slide. So let's have a look at some of the key resilient patterns and design approaches that can be considered to achieve software resiliency. A well designed application scales up and scales down as demand increases and decreases, and is resilient enough to withstand service disruptions. For example, a scalable cloud infrastructure with multiple availability zones can automatically transfer workloads to another zone if one zone experiences a failure. Different technologies for auto scaling work at different speed, so it's important to choose the one that fits the need for your application. However, keep in mind that in some cases, scaling up too quickly without adequate resiliency measures in place can actually increase the risk of failures or outages. For example, if a system is scaled up quickly without sufficient testing and optimization, it can cause overload and instability in the system. This can lead to performance issues, crashes, and downtime, making the system less resilient to unexpected events. Therefore, it is important to scale up gradually and ensure that other resiliency measures are in place at each stage of the scaling process. Containerization can help to improve the scalability and agility of a software system, making it easier to adapt to changing conditions and recover quickly from failures. For example, containers can be quickly deployed and scaled, allowing for faster response times to changes in demand. This can help improve resiliency by ensuring that applications they always remain available and responsive even during high loads. Leveraging managed services can also help as they publish the vendors publish uptime and availability. For example, also managed services providers can monitor systems and infrastructure proactively to identify and address potential issues before they become significant problems. This can help in preventing downtime for your applications and maintain system availability. Managed service providers also typically they offer backup and recovery strategies, redundant systems, and failover mechanisms. Availability, I think availability and resiliency are very closely related, and availability is an important component of resiliency. Uh, a system that is highly available is more resilient because it can continue to function during unexpected events such as power outages, network failures, or hardware failures. A resilient architecture typically involves the use of multiple layers of redundancy and thus increasing the availability of your application by deploying several instances, possibly in different zones or regions. Highly available architectures aim to maximize service availability. Implement disaster recovery and backup solutions that can help you recover quickly in the event of a catastrophic failure. Replicate data and services to a secondary location. Implement automated failover processes and regularly test disaster recovery procedures. By leveraging observability tools, I think we have stressed enough that organizations can enhance their ability to withstand and recover from unexpected events and disruptions, minimizing the impact on users and business operations. Adopt a design approach that enables software systems to be easily monitored, diagnosed, and optimized. It is important to define SLIs and SLOs for your critical services and constantly monitor them. That enables you to get a comprehensive view of a system's behavior, performance, and health. By monitoring trends and patterns over time, observability can actually help identify potential issues before they occur and take proactive measures to prevent them. Implement infrastructure monitoring that continuously provides the health and performance of your application. Implement application monitoring that can provide insights such as we saw, response times and error rates into problems that inframetrics cannot provide. And again, I think adopt SRE practices for dealing with failures and implement strong processes of incident management. Coming to application design, I think in modern software architecture, where an application consists of multiple distributed collection of complex processes, A resilient architecture often includes the use of modular, loosely coupled components so that failures in one component don't bring down the entire system. Stateless applications, applications that are stateless, they facilitate scalability and recoverability. Design for self-healing, Design for self-healing and auto-recovery. It is important to apply the right coding and design patterns to isolate faults and avoid cascading failures. There are patterns such as circuit breakers, retry, timeouts that can improve resiliency and fault tolerance. The pattern allows for graceful. These patterns they allow for graceful degradation and automatic retry, ensuring that the application or service can recover from failures and continue to provide reliable service to users. Building scalable and resilient applications also requires automation. Automating your infrastructure provisioning, testing, and application deployments increases consistency and speed, and it minimizes the human error. It also improves the reproducibility of your applications and environments. Automated testing and automated monitoring can help to detect and diagnose issues more quickly, reducing the time to recovery and improving the overall resiliency of a software system. And finally, it is important to keep evolving and keep continuously validating your design and architecture with chaos testing, in addition to the other forms of testing that we are typically used to. Just remember, early and frequent validation can help to detect and resolve issues more quickly, reducing the risk of costly defects and delays. So I think these patterns, and there are much more, along with many others, that can help software systems to be more resilient and better equipped to handle unexpected events and failures. So, enabling NREF also enables the execution of large-scale chaos testing. So, how does NREF help in doing that? For testing at scale, chaos testing involves simulating a large-scale environment, which could involve thousands of servers, distributed teams, distributed applications, network connections, and other components that make up a complex system. NREF helps you test chaos experiments at scale for large organizations that have multiple development teams working on different features or products by integrating with their own development pipelines. In the next slide, we'll just quickly see how the framework helps us to achieve that. The framework helps in creating a culture of resiliency, enabling teams to continuously monitor and improve the resiliency of their systems, and thus, help to improve the overall resiliency of the entire organization. The central resiliency team identifies and defines a set of automated processes and tools, test scenarios, and libraries that can be integrated with any CI/CD pipeline. They also engage in providing training, knowledge sharing, and collaboration across teams and departments to adopt continuous resiliency testing independently at the granular service level to a more integrated way of testing in lower pre-production environments till they gain confidence in their systems and eventually shift right and run in production. Okay, so I think we are almost towards the end. So once again, here is our NREF framework that enables you to measure, learn, and build solutions to deliver a consistent user experience. This framework is complemented with our solution accelerators, which helps customers accelerate the resilience journey at every stage. Very quickly, some of these accelerators that are part of the framework are assessment toolkits. These toolkits essentially consists of tools, templates, and guidelines to assess an organization's systems, their processes, their operational readiness, and their practices. It contains it has data gathering templates in form of questionnaires, provides templates that can be used to document assessment findings and recommendations. The Nagarro resiliency maturity model, which we saw earlier, is a model to indicate where the organization stands in the journey of achieving resiliency maturity and the target roadmap. The time it takes, I think, to mature resiliency depends on a number of factors, including the complexity of the system, the maturity of the organization's processes and practices, and I think most importantly, the commitment level of the organization itself. We have a reference architecture for observability, which is scalable, flexible, and easy to use, enabling developers and the operations teams as well to quickly identify and resolve issues, optimize performance, and improve the overall quality of the system. The reference architecture also includes recommendations for how to integrate the different components, such as metrics collection, tracing, log aggregation, visualizations, and alerting. It also contains best practices for data management, security, and scalability. Continuous resiliency testing and photon frameworks, they enable automated chaos testing with automated infrastructure provisioning for distributed load generation globally. Integrated with CI/CD pipelines that helps to improve the overall quality of the software, leading to a greater user satisfaction and better business outcomes. And finally, reference architectures or blueprints that we have developed based on industry best practices, standards, and our own experience for building resilient systems that provide a better customer experience, which can lead to increased customer satisfaction, loyalty, and revenue. That's all I have for today. Hope this session was helpful to understand the entire resiliency journey, the building blocks around it, and how our framework helps in implementation. Thank you, everyone, for joining in. If there are any questions, we would be happy to answer.
Awesome. Thank you so much. I think there's tons of questions, a lot of concise and amazing workshop. So yeah, would you want to take like in certain order? Let me know.
Yes, Ed, we can go ahead. I think I saw a few of them. I'll let Sid rest his throat for a minute or so, and I can try answering a few of them, and then we can check if Sid wants to answer
Sure.
further. Okay, I think there is one for serverless, which I saw that how do you do serverless chaos attack or testing. I think you have to collaborate with the CSPs for this. We have had experiments with one of the cloud providers. They really collaborate well with you, wherein you can um, either write your custom chaos, provide them, or you can tell them what you're actually looking out for. Also, the cloud providers are coming up with their own fault injection tools, which you can try out. AWS FIS Chaos Studio for Azure is something that they are continuously building. Yes, it is in process, so you might not have for everything, but we have had success with certain cloud service providers who are ready to collaborate and help us understand that if in case the services are unavailable or how the applications would be impacted. Also, I think the other way to test is also by misconfiguring or making some configuration changes, uh, which would be manual, but yeah, you can try that as well. So I think that was your question, so hopefully that answers that.
Yeah, yeah. It was actually asked by.
Yeah, it was in the chat. I realized. Yeah.
Yeah. Cool.
Okay. Then there is how you handle errors caused by users with payment flow and who gave invalid credit card. So I'm not sure what does invalid credit card, but I would say that you can differentiate between the type of errors. So do not only so when we count for error rates, it depends. So there could be users who are if you're counting for login, maybe there are unauthorized users trying to make a payment. So there is one kind of filtering that you can do based on client side errors and server side errors. And besides that, also if you want to filter further, you can do log based matrices also. So if you have a successful payment and invalid payment, so that is where setting up of correct matrices or observability should be in place, wherein you are able to realize that actually this is happening because somebody is intentionally or maybe the client is doing it, or is it because our systems are not working well.
Right. Got it. So
Then Prasoon's question is done. Okay, then there is how are we configuring which application to target and required latency in the pipeline. Uh, Currently, so you can provide to, I think, the pipeline that I showed, which was being triggered as a part of the demo, uh, accept certain amount of parameters which are shared with the developers. So you can actually build a CSV with those parameters itself and tell how many experiments or which experiments you want to run. So it accepts parameters in form of CSV, and we are building it to accept JSON and other formats as well. Um, that is how we are configuring which application to target. Yeah, and required latency. Again, all the parameters that you require for chaos, that includes, I think, majority is also the duration, how long you want to run the attack, what amount of latency you want to inject, which service you want to inject it with. Those kinds of parameters are being passed via CSV in this case.
Got it. Right.
I think most of them are answered. There is one more, which there is one. Is the staging? So, Sid, if you would like to answer this, or I can also add. Yeah, is the staging environment size to mimic production, or
So
is yeah? Go ahead, Sid.
so I think, Vijay, so typically I think if you are in a cloud native, I think it becomes much easier to mimic a production like environment. Typically, if you, for example, if you want to do a performance testing in a cloud native environment, it is very quickly to spin up a new environment which is quite similar to production, and run your performance testings or chaos testings around it. But typically, I think very importantly, we've seen in most of the our customers who are on-prem rather, right? I think it's a pretty common practice for everyone, where their lower environments are usually never the same as production. And this is one of the challenge that we do face, where the lower environments, even UAT for that matter, for customers that do have a kind of a performance, testing environment. So that's something that's what we would like to leverage. But in cases where the lower UAT environments are definitely not exactly to the production environment. They are much smaller in terms of the capacity, in terms of the redundancy, in terms of how the services are deployed. So that's one challenge that we do face. That during our implementation.
Yeah. Understood. Got it. Cool. I think, yeah, tons of questions, very insightful session. And if you guys still have more questions, there's a Slack channel on the yeah, CC23 sponsors Nagarro. You can go and ask your questions there. You can also join them on the booth and ask your questions there. Yeah, thank you so much, Tarun and Siddharth, for the amazing session. It was great having you guys.
Great, thank you,
And
Shan.
Thank you.
stay tuned for the next one. The Chaos panel is going live right up next. And yeah, it's going to be amazing as well. Very interesting people, very interesting things to talk about. So yeah, thank you guys again for joining and stay tuned. Bye.